All right, today we're going to talk about finding the center and radius of a circle. Yesterday, remember, we introduced conic sections. Okay, there were 4 different types of conic sections. Who can give me the 4? What's one of them? Ellipse is one of them. Circle, hyperbola, and parabola. Those are the 4 conic sections we talked about. From here on, the rest of the chapter, we're going to kind of talk about one of the specific conic sections each day. Except for circles, we're going to do that 2 days, actually. Lucky you guys. So today, we're going to find the center and radius of a circle. This is the second half of section 10.1. First off here, main idea of what we're talking about today. The diameter of a circle is a straight line segment that passes through the center of a circle. Basically, we've all kind of worked with circles dealing in geometry. Let's say I have a circle that looks like that. This black line should represent my diameter. Everybody good with that? You recognize that, right? You don't recognize that.
No, it's a no.
Oh, it's the no sign. I got you. I got you. And then if you know the coordinates of the endpoints, the diameter of a circle, you can determine the location of the center of the circle and its radius. For example here, what's the relationship between the diameter and the radius? Yeah, the radius is half the diameter, right? So if I had the diameter here and I want to find the radius, I can find the distance and then divide by 2, which is one of the things we're doing today. The other thing we're going to do is we're going to find the center. In a circle, where is the center located in terms of like the diameter? Okay.
The midpoint.
The middle or the midpoint. Okay. So 2 things we're going to do today. We're going to use the midpoint formula to find the coordinates of the center. We've done the midpoint a lot this year. That should be pretty relatively easy. And we're going to use the distance formula to find the radius. We've used the distance formula a lot this year. So 2 things we've done a lot. We found the distance and we find the midpoint. So this is what kind of problems we're going to look at today. For a circle with a diameter with endpoints 2, 14, and 5, 18, the center is located at, and then from here I find the midpoint. 2 plus 5 is 7. 7 divided by 2 is 7 halves, or 3.5. And then 14 plus 18 is 32. 32 divided by 2 is 16. My midpoint, or my center, is located at 7 halves, 16. Pretty straightforward. And then they tell you, they kind of give you an example here. They tell you to use the endpoint and the center, which you can do. So if I use the center and the endpoint, I'm actually calculating the radius. But sometimes your center is like a fraction, so it makes it harder. So I most times do this. I find the distance of the diameter, and then I divide it by 2 because that's my radius. You can do it either way. It's not going to make a difference. All right, so useful hints here. You can make sure you calculate the radius correctly by using the endpoint of the diameter and the center of the circle in the distance formula. The radii you calculate using both endpoints should be the same. All right, take about 30 seconds, turn to a partner, re-emphasize what I just said. All right, so let's move on here. So first one here, number 1. We want to, one diameter of a circle has endpoints negative 2, 8, and 10, 8. And I want to find the center, the radius, and I'm also going to calculate area and circumference. So we'll review both of those. So as we just got done talking about here, they give me 2 endpoints. And I want to find the center of the circle. In order to find the center of the circle, I need to calculate the midpoint. So take 15 seconds here, 30 maybe if you need to, and find the midpoint of those 2 coordinates. All right, ready here? So what's the midpoint? What's the center of the circle going to be, Ethan? 4, 8. Yeah, the center of my circle is at 4, 8. Awesome. Part B says find the length of the radius. To find the length of the radius, I need to calculate the what here? I need to calculate the distance. Now, there's 2 ways to do this here, right? I can find the distance of my diameter and then do what with that? Divide by 2. Or I could take my center coordinate with either of my other coordinates, and that would give me the radius. Okay? I like to do the diameter, though, so I'm going to do this one here. What's the difference in my x values? 12. Difference in my y values?
0.
So square root of 12 squared plus 0 squared is, what's that, square root of 144?
Yeah.
Which gets me
12.
12. But that's my what, though?
Diameter.
That's my diameter.
So 6.
So what's my radius going to be then?
6.
Cut that in half. My radius is 6. Then we're going to extend this a little bit. And part C says find the area of the circle. Now we're going to leave this in terms of pi, which we did a lot of that back in geometry and kind of throughout this year. Area of the circle, remember, formula is A equals pi r squared, where r stands for the radius. So I'm going to take the radius. 6 squared is. So my area is going to be 36 pi units squared. And then I have the circumference. Circumference of a circle is C equals 2 pi r. Again, r stands for the radius. So I double my radius, and that's going to be 12. So my circumference is 12 pi units. Pretty straightforward, right? Good work. All right, number 2 now. The center of a circle is at 2, 0, and its radius is 3 units. Find the endpoints of one of its diameters. To help us kind of look at this one, I'm going to graph this here. Okay, so I'm just going to create a grid here. I'm going to graph it. All right, so it tells me the center of the circle is at 2, 0. And its radius is 3 units. So from that center, how do I find the edge of the circle?
Count out 3 units.
I'm going to count out 3 units. So which way should I count?
Anyway.
Like, can I go 3 units this way? Does that work? What?
You can go ahead.
I can go any way, right?
Yeah.
But if I'm counting units, which way is because I'm on the grid here? So which way is easiest to start with? Put that way.
Right.
Okay, let's go right first, right? So I'm going to go 3 units right. 1, 2, 3. And I'm there. And then if I'm going to go right, which other way should I go? Left. 1, 2, 3. And then which other ways could I go if I want to go right? I can go vertically, so I go up or down, right? 1, 2, 3. 1, 2, 3. And that gives me kind of the points there that I can use for my circle. Okay? I have a pretty cool circle tool. It's all right. But then the answer to the question is find the endpoints of one of its diameters. Well, when I'm on the grids, on the coordinates here, that makes it a lot simpler, right?
6, 0.
Like, would everybody agree that's a diameter right there, that yellow line? So what are those 2 coordinates there that I found?
5, 0,
Yeah, 5, 0, and -1, 0. What if I don't like the horizontal diameter? What if I want the vertical diameter? What are those coordinates? No. 2 what? 2, 3. And 2, -3. Awesome. So pretty straightforward, right? Yeah, that's bad. Again, if I look at my center here, if I add or subtract 3 from the x value, that's where I had the first one. And then if I add or subtract 3 from the y value, that's where I get that second diameter. All right? Let's move on here. So number 3. Find the center and radius of a circle that has a diameter with endpoints 5, 4, and 0, -8. Well, we kind of talked about this already. In order to calculate the center, or in order to find the center, I need to calculate the what? Midpoint. All right, take about 20 seconds here and calculate the midpoint of those 2 coordinates. All right, so what do you have for the center or the midpoint here? Kate and Scott. 2.5, -2. Awesome. And then I want to find the radius. To find the radius, what do I need to calculate? The distance. So I'm going to give you about a minute here. Calculate the distance in order to find the radius. Go. All right, so let's go through this here. What is the radius then?
6.5. Maybe.
6.5? Yeah. Because when you calculate it, if you calculate it this way, what's my diameter's length? Yeah, the diameter is 13. Then I cut that in half, and I get the radius is 6.5, 6.5. Awesome. All right, number 4. Find the center and radius of a circle that has diameter with endpoints 312 and 9,4. So again, let's start off finding the center. In order to find the center, I need to calculate the midpoint. Looks like most of you are already done with this part here. What's the center or midpoint there, Gage? 6.8. Awesome. And then I need to find the radius. In order to find the radius, I need to calculate the distance. So I'm going to give you about another 30 seconds here to finish that part up. All right, so let's go through this here. Hannah, what do you have for the radius then? What'd you get? 5. Yeah, when you calculate it this way, the diameter ends up being 10. Cut that in half, and my radius is 5. Nice work. All right, now try these two on your own here, or with a partner, I should say. Find the center and radius of a circle that has diameter with the given endpoints. So do numbers 5 and 6 the partner here. I'm going to give you about 2-3 minutes. Go.
2 to 3.
All right, so let's go through these here. First one, number 5. I want to find the center. Mallory, where's the center going to be located at? 5 and -3. And what about the radius then? Grayson. Yeah, my radius is 5 units. Awesome. And then number 6. Zach, where's my center located at?
4.6.
Close. -4.6. Yep. And then what about my radius there, Billy?
17.
My radius is 17. Awesome. Nice job. All right, we're going to extend this a little bit and do a little problem solving. Oh, wait, before we get there. That's right. With the partner, could you calculate the length of the diameter of a circle given the coordinates of the center of the circle and the length of the radius? I repeat. Could you calculate the length of the diameter of a circle given the coordinates of the center of the circle and the length of the radius? Explain. Turn to partner and explain. All right, so what do we say? Can you find it?
Yes.
Yeah. I think Kelsey said it right. If you have, as long as you have the radius, you can find the diameter, right? You don't need the center. Yeah. Nice. All right, now let's extend this here. So a little problem solving here. Hunter and Max draw a grid over a map of their town so they can determine precisely where to set up a broadcast station. Hunter decides that locations A and B should be the endpoints of the diameter of a circle around the broadcast station. Number 7, locate the center of the circle using the midpoint formula in points A and B. If you locate here, here's point A, point B is down here. Okay, so number 7, what do you have to do? You have to find the midpoint. Pretty straightforward. Number 8, find the radius and the circumference of the circle. Name the coordinates of 2 points you can use with the distance formula to find the radius. Use the distance formula to find the radius, and then see what is the circumference of the circle. You and a partner, I'm going to give you about 3 minutes. Do numbers 7 and 8 here. Go. Alrighty, so number 7 here. Locate the center of the circle using the midpoint formula in points A and B. G. Hoff, what'd you say? Where's my center going to be located at?
1.5,
Yeah, 1.5 here and -1. So if I locate it down here, again, recognize my grid is on a scale of 2. So 1.5, -1. My midpoint should be about right there, that purple dot. And then part 2. Number 8 here. Find the radius and circumference of the circle. Name the coordinates of 2 points you can use with the distance formula to find the radius. Did most people probably use A and B? Yeah, I would use A and B. What, A is at 4.7 or 4.5, sorry. And B is at what, -1, -7? So I'm going to use those 2 coordinates there. And then I'm going to use the distance formula to find the radius. Kelsey, what's my radius going to be then? Yeah, my radius is 6.5. And then what's the circumference of the circle? Do you leave yours in terms of pi or not? What's your answer in terms of pi then? It is, 13 pi. Yeah, sorry. So 13 pi units. Good work. Now, let's extend this a little bit further. And see what Hunter's got to say here. Hunter says that point C is within the circle. Max says that point C is on the circumference of the circle. Explain how they can use the distance formula to determine the answer. So looking back here, there's point C down the bottom right down there. How could we calculate whether C is on the circle or inside the circle? What do you say, Avery? How could we use the radius? Yeah, we don't see how far the distance is, but it's kind of at a angled here, right? So it's not like we can just like count units though, right? So Billy, what'd you say?
The distance from the center.
Yeah, I can find the distance from the center, right? So what we want to do here is we want to find the distance from the center to C. And if the distance is less than 6.5, what's that telling me about C? It's inside the circle. And if it's exactly 6.5, then it's on the circle. And what if it's bigger than 6.5? Then it's outside the circle. So take about a minute here and calculate the distance from the center to C. All right, Jess, help me out here. So when you calculated the distance there, what did you find the distance from center to C to be? Someone help her out? Yeah, the distance here should be about 5.4. And remember, what was our radius distance? So was it inside or on the circumference?
Inside.
It is inside.
And we're done.
So who was correct then?
Hunter.
Hunter
Not Max.
was correct.
Max was
Awesome.
wrong.
And here's your assignment.